This video is to explore the relationship between pressure and temperature. So as we change the temperature, that would be my independent variable, we're going to see how the dependent variable pressure changes. So to do this, I have a Bunsen burner. It's sitting over here. You can see it there. I have a flask sitting on a ring stand. You'll notice that the little blue, there's a little blue valve at the top of the flask, and that valve turns it on and off. So on and off meaning air can get in or air can get out. Right now I have it set so that no air can get in or out. So it's closed flask. As you can see that tube running off. The tube runs to a little pressure sensor that's behind the computer. And I'll get it set up so you can see the screen well. But I want you to see the whole screen, so let's do that. All right, there we go. So the little pressure sensor is behind the computer right here. The pressure sensor then is connected via USB port to the back of the computer. I'm going to turn the computer on, the collection on, and you should see a little red line start to form about 100 on the y-axis. Now you notice that line is just flat. It's not really changing. And the reason that it's not changing, of course, is because I haven't begun to heat the flask yet. I wanted to also point out that the unit on the y-axis is, it says pressure, and then in parentheses it says kPa. I'll be spending some time in a different video discussing units of pressure and how we measure pressure. So kilopascals is what kPa stands for, and kilopascals are kind of like pounds per square inch that I discussed in a different video. It's a force per unit of area, and the direct analogy is a singular pascal to a psi. But since pascals are not very big, we usually use kilopascals. So I've let that run for long enough that you can see that the pressure is remaining constant inside the flask. Remember, the flask is sitting over here on the ring stand, and its pressure inside is stable right now. So I'm going to begin to heat it. So I'm setting the burner. I'm going to set the burner onto it. I'm turning down the gas just a little bit. I'm heating a little bit more slowly than I have in my trial runs earlier. But you can see probably fairly quickly that the little red line is going to go up. And I'm going to put on auto scale so that it's a little bit more dramatic. But there you can see it changing on the right side. It's gone up about 10 kilopascals right now. I'm going to take it off, pull the fire away, because previously when I was doing a trial run I melted my hose. So we can see that as I pull the burner away, that the pressure did not increase as dramatically. As a matter of fact, it's going to begin to cool, and as it begins to cool, the pressure should begin to go down. So the relationship between pressure and temperature is a direct relationship. So I'm going to go to the board here and remind you of things we've talked about earlier. Okay, so in this case, our independent variable was temperature. So we were increasing the temperature. When we increased the temperature, the pressure we saw increased. We didn't change the volume of the container, so we just put it as constant. And now we have a third gas law. That gas law says that pressure is directly proportional to temperature. As the temperature goes up, the pressure goes up. And we call that, most often, it's named after a French scientist from many years ago named Lussac. So Lussac's law, that is, pressure goes up, temperature goes up. So three laws, three basic gas laws. In terms of the kind of relationships they are, this one is an inverse relationship. That means as one goes up, the other goes down, while the third variable is constant. These two relationships are direct. As one goes up, the other goes up, assuming that the third variable is constant. So that's a little summary of gas laws. Before I turn this video off, let's take a quick look at what's going on inside the flask, and you can see that the pressure is continually decreasing as the temperature goes down, so they certainly are a direct relationship.